So, greetings of the day, myself Dr. Kanksha Dubey, Assistant Professor at Christy Jayanti College from Department of Life Science. Today we will be talking of reaction intermediates. So, reaction intermediates is nothing but a transient species with a multi-step reaction mechanism, and it is produced in preceding step and it's consumed in the subsequent step or succeeding step to ultimately generate the final reaction product. Now, we have different types of reaction products. Basically, we have 5 different important reactive intermediates here, that is carbocations, carboanions, carbenes, free radicals and nitrines, which we will be discussing one by one. So, first we have carbocation here. So, what are carbocations? Carbocations are organic ions which basically contains positively charged atoms and are called as carbocations, carbonium ions or carbanium ions. Now, this carbocation can either be carbanium ion where it is trivalent positive species and can also be carbonium ion where it is pentavalent positive species, which is also termed as non-classical carbocation. Next, talking of properties of carbocations, so they are very reactive and unstable due to their incomplete octet. They are positively charged atoms with 3 bonds, as it is clearly evident in the diagram for both top view and side view. Next, we have silent features of carbocation. So, as I mentioned, it is a positively charged carbon atom that has 6 electrons in its outermost shell or valence shell. So, generally it is told that it undergoes sp2 hybridization and has trigonal planar structure, as you can see in the diagram. When we talk of sp2 hybridization, that means it has 1 s and 2 p orbitals where 1 unhybridized p orbitals are present. So, talking of the features again, it is electron deficient and so it acts as electrophile and is represented as R. Now, talking of order of stability of carbonium ions, so it has in decreasing order from primary, secondary, tertiary and methyl. When we talk of secondary, tertiary or primary, that means the number of alkyl group it attached to carbon atom. As you can see, in case of tertiary it is 3, in case of secondary it is 2 and primary will have 1. Next, we have a formation of carbocation. So, carbocation is organic molecule, an intermediate that is formed as a result of loss of 2 valence electron, normally the shared electrons from carbon atom that already has 4 bonds. Now, this leads to formation of carbon atom bearing a positive charge and 3 bond instead of 4. So, the whole molecule holds a positive charge carbon atom and therefore, it is represented as carbocation intermediate. Next, talking of formation, so it might occur in 2 forms, that is one by heterolytic bond cleavage, the other by protonation or electrophilic addition. Now, when we talk of heterolytic bond cleavage, it is clear example of cleavage of carbon and alkyl group bond, which is heterolytic cleavage where means 2 different atoms can be obtained. Here example is ionization of alkyl halides where you can see a carbocation is obtained and the leaving group iodine has left. Now, another example we have determination of amines by nitrous acid where you can see that when amines are reacted with nitrous acid, carbocation is formed as R plus and nitrogen comes out. Another example is for protonation, as I mentioned. So, here protonation is nothing but electrophilic attack where HBr will give electrophilic attack and protonation of alkenes will happen and bromine will leave as a leaving group. Now, another example is protonation of alcohols followed by dehydration where you can see alcoholic group is removed and it forms an intermediate of OH2 and further water comes out. Next, talking of stability of carbocations, so it is responsible basically on 3 effects, that is inductive effect, resonance effect and hyperconjugation. Talking of inductive effect, so it may be positive inductive effect or negative inductive effect. Now, the atom or a group of atoms which donates or share electrons termed as positive inductive effect or plus I effect. So, electron donating or releasing group shows plus I effect, whereas the atoms or group of atom which withdraws or attract the shared pair of electrons are under the category of negative inductive effect. So, here it can be termed as electron withdrawing group shows minus I effect. Now, the stability of carbocations increases when the plus I groups like alkyl groups are present adjacent to positively charged carbon atom, whereas if minus I groups are present, it destabilizes the carbocations as they increase the positive charge by withdrawing the electron density. Here we have an example where you can see a decreasing order of stability of carbocation. Next, talking of resonance effect. So, positive resonance effect occurs when the group releases electrons to other molecules by process of delocalization, and it is denoted by plus R or plus M effect. For example, OH group, OR group or SR group, whereas negative resonance effect is when groups withdraw the electrons from other molecules by process of delocalization. Again, it is denoted by minus R or minus N. For example, NO2 group, carboxyl group, CN group. Now, talking of stability of carbocation based on hyperconjugation structures. So, here the greater the hyperconjugation structures, then greater the stability of carbocation. So, here as you can see, the decreasing order of stability of alkyl carbocations, where tertiary has 9 hyperconjugation structures, secondary has 2, primary has 3 hyperconjugation, and methyl does not have. Therefore, it has decreasing order of stability in case of hyperconjugating structures. So, thank you and have a nice day.